Can you see my screen?
All right, somebody hit.
Then a quick intro to Couchbase, what is it, and then into migration options, finally rounding out with optimizing, and then over to Rick for a live product demonstration. So first, a quick introduction to NoSQL. When most transactions were offline and people browsed or met in person to conduct business, batching data and relatively low volume transactions were really the norm. Applications could keep up, and there simply wasn't the need for truly massive application scale back in the in-person era, if we can all kind of remember that. But now, and especially within the last year, of course, everything has moved online, and this adds strain to applications that simply weren't architected to handle that demand. I mean, these days, everything is online, and users look at hundreds of things before doing something like making a purchase. Supply chains are monitored and managed often in real time. Where's my package? Where did the assembly line problem occur? And everything in the modern era captures and produces data. And this drives volumes of both reads and writes way up. So enterprises have started turning to NoSQL databases to handle the increased volume more efficiently and with better scale. However, the first generation of NoSQL databases didn't do things like joins, and they didn't support SQL. They didn't do transactions. But people put up with them because they had to in order to meet performance and scalability requirements. But they did their real work often offline on mainframes and RDBMS, relational systems. And now with business changing more rapidly, uptime requirements reaching 100% and everything moving online, the NoSQL architecture is even really more relevant and essential. Moreover, now you need to analyze in real time. There's no longer tolerance for taking the time to ship data to some other system, do some ETL, do some processing, and then do some analysis. Analytics has to happen now in real time. So that's why Couchbase, as a modern NoSQL database technology, supports SQL, supports joins, supports transactions, and it provides an embedded MPP for real-time analytics. So there's no need to bolt on these types of capabilities in order to achieve those requirements. Couchbase specializes in handling high data volumes reliably and with zero downtime. The most common NoSQL databases use JSON documents to store and represent data. And JSON is JavaScript object notation, as you probably know. It embeds key value pairs and arrays, and it can also embed sub-documents, or really a particular string. And it can represent numbers, strings, and Boolean values, of course. JSON is supported by nearly every major language and platform on Earth. I mean, arguably, it's the de facto language of modern services on the internet. Even if your database doesn't support JSON, your application and application services are likely speaking JSON. So let's examine what a JSON document is. It's most analogous to a row in a relational system, an RDBMS. Different NoSQL databases have different storage paradigms, but Couchbase stores documents in what we call a bucket. But a bucket is more like a database instance than a table. A relational table is most analogous to a set of JSON documents with the same type, which we generally concatenate as part of the ID. So I can essentially represent my relational tables on the left as sets of JSON documents on the right. One thing to note, though, is that while RDBMSs generally enforce constraints, NoSQL databases generally support agility or schema on read. Meaning that I can add a field to a document or omit a field from a document on the fly. There are various reasons that this is better, but it does mean that you have to keep in mind that any constraint enforcement then moves into the query or to the application layer. Another thing is that it's different is that generally timestamps are either a string, array, or number. Conversion is handled at the query level, so we recommend using epoch, the number style, or Unix time. So now let's get into Couchbase. We sort of got an intro to NoSQL. Where does Couchbase fit in? Well, Couchbase is a distributed NoSQL database that delivers unmatched versatility, performance, scalability, and value across cloud, on-prem, edge, and hybrid deployments. And when we consider how Couchbase is different from other modern databases, there are really three key areas where we win with our customers. First, in agility and flexibility for developers. Couchbase accelerates application development by capitalizing on that ubiquitous query language, SQL. Everybody knows SQL. It offers full text search and adaptive indexing, along with seamless data synchronization, all as core features of the software. And customer studies show that these tenets enable a 20% faster development lifecycle for applications. Next, Couchbase offers predictable performance at scale for IT architects. The server can handle any volume, volatility, or speed of data, any number of sources, and any number of end users with an in-memory dataset process, smart optimization, and highly performant indexing. Customers report that their applications show a 10 to 20x better performance on Couchbase. And it's the easiest platform to manage for DevOps. Couchbase helps you streamline setup and configuration, take advantage of multi-cloud agility, and helps ensure availability with those coveted 5 nines, 99.999% reliability. Customers report 37% more efficient database management and 14% lower database licensing costs using Couchbase. Couchbase supports transactions, SQL, and full text search. It's a memory-first, shared-nothing, distributed architecture. And what this means is that the default behavior is that you can read or write from any node. The write will be put into memory and replicated to at least one node. It'll be written to disk later, and this is configurable. Your application moves on. So if any node goes down, your clients don't care. They just connect to a different node. Data reliability is assured through that replication. And I want to make sure everyone gets a sense of how SQL on JSON works. So we've sort of peppered a few examples around the slide. You can see an insert statement, creating an index, a select, and a delete. And these are examples of N1QL, or nickel queries. Nickel is Couchbase's query language modeled on and just as easy as SQL. Couchbase Server is really the basis of our value. But don't just take my word for it. The readers of database trends and applications voted Couchbase as the best database overall in this year's DBTA Reader's Choice Awards. Couchbase also won the Best in-Memory Database category for the 3rd consecutive year. We also received finalist distinction in categories of Best NoSQL Database, Best IoT Solution, and Couchbase Cloud makes its debut on the annual Reader's Choice list as a finalist for Best Cloud Database. We're really honored to have received this recognition, and I think it really speaks to the value that customers get from the technology. Couchbase runs on-prem, in your own cloud, across multiple clouds, or you can take advantage, again, of our fully managed database as a service, Couchbase Cloud. And there's a free trial that you can use to try out even your migration efforts and see for yourself how easy it can be. So we'll also mention that a little bit later in the presentation as well, where you can go and get your free sign up. So we're focusing on Couchbase Server today, but Couchbase supports edge computing with an embeddable database and gateway that allows local, peer-to-peer, and client-server edge applications, all communicating across these various tiers. Couchbase Server to Couchbase Lite via Sync Gateway allows you to achieve edge computing. This model enables resilient applications that really maximize uptime and minimize latency. Whether this is at a big box store or factory floor, or if your connection to the cloud is lost, your applications go down and you suffer business downtime. But Couchbase supports this distributed cloud to edge model that moves data and compute closer to applications, and that guarantees uptime and really eliminates latency. So whether you're in the cloud or deployed across a set of data centers, Couchbase supports high availability through replication and disaster recovery through cross data center or XDCR. And this lets you support multiple data centers or multiple geographic zones in the case of a cloud. The feature is highly configurable to allow for the optimal balance of replication based on any given use case. And in essence, you gain the ability to read and write locally and have the right data go to other geographies. So XDCR is highly performant, independently scalable, and infrastructure agnostic, topology aware, and resilient. And it helps you meet those availability requirements for any application. All right, now let's move into some of the migration options. We've introduced the concepts of NoSQL and what Couchbase is. Most applications that go to NoSQL are greenfield, but we've also started to see more migrations recently from relational backends. And there are really a lot of reasons for this. So the number one reason in our experience is that there's an application that works, but now has to scale. Now there are new demands that it wasn't really designed to handle, whether it's because a cell provider wants to give more users more visibility into their data usage by making an external service remotely available, or perhaps as a retailer that suddenly has a lot of online orders, or a financial services firm that has increasing data volumes and is pursuing a more service-oriented and consolidated architecture. Each of those examples follows this general pattern. Lots of change, very rapid, and the need for more reliability and better scale. When we strategize a move from relational to NoSQL, we need to think about some things. What level of risk are we willing to tolerate? What skills and expertise do we have? What's the cost of migration? And what are our performance and scalability requirements? Make sure that you actually have a lot of these considerations already taken into consideration. You've got started thinking about it before you start to approach your migration. So there's different options that we have when pursuing a migration. And this visual sort of depicts the options on a scale from the highest risk and effort to the lowest. First, do we want to rewrite the whole thing? That's a lot of effort, presents a lot of risk, but it does give us an opportunity to achieve the most optimal performance and scale on the NoSQL end. Another option is to migrate the database and totally rewrite the data layer in the application. Little less effort, little less risk, but still enough that you want to think about it. Performance and scale is probably almost as good as rewriting with this approach. Another option is that we can keep everything as is, but refactor our data, logic, and RDBMS schema into a best practice schema. We're keeping our business logic, most of our data logic, but pursuing optimization up front. Or we can optimize later. Basically, just migrate table rows to documents and make as few changes to our queries as possible. Our initial performance and scale might not be great with this particular approach, but it does work, lower risk, and it gives a basis on which to optimize once that migration is complete. And finally, we could just not bother optimizing and just simply host it. So we're really balancing performance and scale with our effort and risk. And generally, we see organizations doing more of an option 3 or 4 than option 1 or 2. And option 5 is typically done for applications that are migrated simply for consolidation reasons, where performance and scale requirements are just not as high. So what we're going to do now is drill into option number 4, migration without denormalization. And this offers the best balance of quick migration and low risk and effort. And then we'll explore optimizing post-migration. So how do we migrate without denormalizing the data into one big document? First, you need a NoSQL database that supports SQL, ACID transactions, and joins. We need to understand how the tables and rows relate to documents. There will be SQL dialect transitions similar to when you go between 2 RDBMSs. Even if they officially support the ANSI standard, we always know some changes are always necessary. And once we get everything running, we might not see the performance improvements until we optimize. We need to really expect that up front. When we move to a distributed architecture, there is a different sweet spot for performance. For Couchbase, a key value lookup will be faster. A query that hits a lot of rows will be faster because we can pipeline it from multiple servers at once. But real performance improvement over your original application comes with optimization, which we'll discuss as we go through the presentation. So let's look at how things relate between your RDBMS and Couchbase. A set of like-typed fields are analogous to a table. Here we can see a relational table on the left and a JSON document on the right. Notice the JSON document has a type, and the type is also included in the ID. The user document type is really analogous to a user table in a relational database. A given document, a single document, is analogous to a database row. Like name fields in a document are analogous to a column. A conventional relational model tries to have minimally redundant data. This minimizes storage, enforces a schema, and handles joins in memory on a single server. It also requires multiple transactions to piece together information across tables, whereas in a JSON document, the related information can be encapsulated within a given document or record. The relational model separates the detail and so requires more work to knit them back together, if you will. A document is fairly denormalized. It generally aligns with how your application uses data. So there's where we have the distinction between constraints within the data schema or that flexibility to really make your constraints based on your application. So this generally aligns with how your application uses the data. That's how you set up your documents. Normal single document reads and writes don't require transactions. So this means fewer joins and fewer transactions, which in short really scales better horizontally. For Couchbase, we query on a bucket. Remember that a bucket is more like a database instance than a table. What gives us the specificity of a table is that we specify the type, the document type. So these two queries are doing the same thing, one on an RDBMS and one on Couchbase. Remember that a relational table translates to a document type in a bucket, and any bucket can store documents of many types. ANSI joins and other SQL conventions are supported. But there are constructs in NCL that are mainly about working with the extra richness of detail that a JSON document can store, such as unnest or nest for working with extended information within documents, such as arrays and child objects. When you create an index, the meta keyword allows you to refer to field names. The global secondary index is called out in this example, but other index types are supported. For the sake of time, we won't get into the details of indexing here. So now we sort of understand at a high level the parallels between relational data and JSON documents. And let's say that we've used this to move our data into JSON and now it's hosted on Couchbase. Our one-for-one relational model is mimicked in NoSQL. So how do we go about optimizing it to take full advantage of the NoSQL performance benefits? The first consideration is that joining and transacting is costly, especially in a distributed architecture, and it doesn't scale as well horizontally. Since JSON documents can embed related information in the construct of a record, you should really consider minimizing joins by eliminating disparate tables and incorporating the detail directly to the record. Next, your well-designed application code is your guide. If in your application person contains addresses, but it looks up orders, that's a good hint that the addresses should probably be stored in the person document type. But you might consider another document type called orders. So by examining your application code, you can start to make these inferences that will inform your optimization strategy. Another consideration is thinking in terms of entities. When planning an RDBMS schema, we think in terms of flattening the data and reducing redundancy. But instead, think of the schema in terms of entities. In the scope of your application, does this entity have a life cycle outside of the thing that always references it? Also, can you reduce the number of explicit transactions and joins required? When trying to optimize, should we always strive to reduce joins? In general, yes, but where it makes sense and where it will have a definite impact on performance. And lastly, have you met your performance and scale requirements? If you begin optimizing and then see acceptable performance, your optimization may be complete. In other words, test for required performance often during your optimization. You may meet requirements with less work than you thought. Let's take a look at reducing transactions. On the left, we have a relational transaction. We're updating a savings account table and updating a checking account table. Multiple actions on multiple tables for a single update. And on the right side, we see the nickel equivalent, where we've put these elements formerly stored in separate tables together into a single document type called accounts. This gives us the ability to do one update across all accounts without the need for multiple transactions. We perform the updates on the same document. And while a simple example here, I think it accurately illustrates the concept of optimizing the model. As a best practice, we want to emphasize use your logical model to guide your optimization. Use your objects to determine what to embed. In this case, we have a given order, and the order has multiple items of various quantities. JSON allows us to embed the details within a document. We can actually put these elements of items and products into a single document, reducing the number of document types or tables in the RDBMS nomenclature. Here we depict how pay type can be embedded into the order, which then refers to items, which embeds product. Again, leveraging the logical model to determine the best embedding options for optimization. We can also leverage references. Products have a life cycle independent from the order, so we may embed the ID of the product and related quantity in the order, but store the product details in a product document type. So in this way, we can reference the product from the order without the need for an intermediate order items join table, because the item quantities are stored in the order document type. And here we see an example of the embedding within JSON documents. And the difference is that on the left, we have a child of the phones object, where there is a home phone number nested under phones. And on the right, we actually have an array where multiple values can be nested under the phones object as multi-value containers of information related to that core object. This is what we mean by sort of embedding that extra richness into a given document. And this ability is one of the keys to the JSON model's efficiency, where table joins are eliminated by embedding extra detail directly to those records. So, some conclusions on migration before we get to Rick's demo. Number one, reduce risk. Make your life a little easier by migrating first, then optimizing post-migration. Number two, strive to reduce joins and transactions in your optimization exercise. Number three, leverage embedding to reduce document types and thus joins. Number four, optimizing can reduce the need for ACID transactions, increasing efficiency. And number five, lastly, when optimizing, have that performance goal established. And when you hit that goal, stop optimizing, you're done. This is because optimization could otherwise be endless. So when performance goals are met, let that be your sign that optimization is complete. As we transition to the demonstration, I'll once again remind everybody that NCL, Couchbase's query language, is almost entirely analogous to SQL. And this is one of the main reasons that developers turn to Couchbase when going to NoSQL, because they can continue to leverage existing code and their expertise of SQL for their applications, while at the same time realizing the efficiency and benefits of a JSON-based key-value data store. So with that, I'm going to change presenters. and turn it over to my colleague, Rick Jacobs. Rick, the floor is yours.
All right, do me a favor and let me know when you can see my screen, please.
All right. We can see your screen.
All right, thank you, sir. So first of all, thanks to everyone on the line for taking the time out of their day to be here. My name is Rick Jacobs, and my goal in this presentation is to show just how easy it is to utilize data within Couchbase and also access that data. So here's a quick checklist of what I'll be going through in this demonstration. So first of all, I'll be looking at the Couchbase UI. We'll take a look at buckets, bucket creations, and creating indexes. I'll also demonstrate the query functionality within that Couchbase UI, and we'll run a few queries. Then I'll show utilizing code to access data within Couchbase, and then we'll do a quick summary. So let's jump into the demo. All right, when you first log into Couchbase, you're greeted with this dashboard screen. This is basically just information on the cluster. Generally, users are more interested in the buckets and the documents within those buckets. So we have here a list of the buckets within this particular cluster. We can do things like take a look at some of the data within those buckets. So we can edit that data. We can edit the size of the bucket, and we can also edit the data within the buckets. So I could look at the documents currently within the buckets. Right now I'm doing a query based on the type of product. So I'm going to go ahead and run that, get some results back. There we go. So I took out the where clause within that query and got some results back based on just the documents within that bucket. So again, we can do things like look at the documents within the bucket. We can go in and edit those documents if we need to. But generally, analysts and developers are more interested in how to query the bucket with SQL code. So we can do things like look at all the records within the bucket. So we can do simple select statements. For example, here we go with a simple select that just gets all the data, the records back from the bare sample bucket with a limit of 20. So here are all the first 20 records within that bare sample bucket based on that select statement that we sent in. As you can see, very basic syntax, very basic SQL syntax that most developers and analysts are very familiar with. You can also do things like group bys. So we've got aggregation functions. So I could run a group by select statement. So here I'm grouping by the bucket type. And this gives us back the types of bears within that, the bear types within the bear sample bucket. And we can do joins, which is not supported by some of our major competitors. So as Mark mentioned before, buckets are basically repositories for data. So you can have several different types within a bucket. A document type is more so what analogous with what we would consider a table to be in a relational database. So this query, for example, selects from the beer and brewery buckets and then does some querying based on the criteria of the state of Wisconsin. Let me try to execute this. Give me 1 second. I'm copying and pasting my select statement, so give me a second. Here we go. There we go. Right. So that query executes and it'll give us a result in a second. Again, this particular query is doing a join between the brewery document type and the bare document types. And then it returns that information based on the state of Wisconsin. Another thing I wanted to show you is how we access Couchbase data from a developer's perspective. Because we've taken a look at how analysts would generally query data within a database. The next thing is, how do developers access that data? So I'll take a quick look at how we access data from a development perspective. So what we have here is a screen that's familiar to many developers. It's just an IDE that we use to code against different environments. On the right, this is a table that's actually sitting in a Snowflake database. So it's the company's table within that database on Snowflake Cloud. Snowflake is a relational database, but it's just housed in the cloud. So it's basically a cloud-based relational database that's distributed. What I have here is some code that connects to that Snowflake database based on this query string. So we're going to run this query on Snowflake, which basically brings back all the records in that company's table. And then we're going to connect to Couchbase and insert that data into Couchbase. So the first thing I want to do is show you what the Couchbase repository currently looks like. Give me 1 second to pull that up. All right, so in Couchbase currently, we have a bucket called Snowflake, and it's got some records in there because I was testing this earlier. So I'm gonna go ahead and delete that whole bucket. Snowflake bucket is now gone. I'm gonna add that Snowflake bucket back. Snowflake bucket is actually, sorry, looks like the delete didn't quite work. Actually, yes, it did. So I deleted that original Snowflake bucket with 300 records, and I created a new Snowflake bucket with 0 records. Now I'm going to go into code and move that code from Snowflake into the bucket in Couchbase. So we're going to expect all these records to now be in Couchbase. I'm going to go ahead and run this. And as I mentioned before, we're connecting to Snowflake, running this query, getting some results back, and then putting those results into Couchbase. So this takes a second because this is going out to a cluster on Snowflake, then connecting to a cluster on my machine with Couchbase, and then moving those records over. So we've got the output saying that the records were moved over, and I can prove that by going to Couchbase, and now we've got 100 records in Couchbase. I can actually take a look at one of those records based on the ID. So what I do to create my ID is I've got the timestamp, and then I've got the location of where these records came from. So based on this exact timestamp, I should be able to pick up that exact record. So we would expect a record looking like this. So I'm going to go into Snowflake bucket. And do run a query on that document. So what I'm doing here is going into Snowflake bucket and looking for that specific document ID. Yep, and that worked. And the other thing I have is I can do the same thing from code. So I have a little Python application that I can fill in the ID of the record I'm looking for, and it'll go out to find me that record. Go ahead and run this. So again, this is going out to Couchbase and doing a search by key. And this is the key it's searching on, and here's the results. So again, same record we just inserted, same record we just pulled up on the UI and then again by code. So the goal of this was definitely to show you how easy it is to access data within Couchbase and how seamless it is to go from a relational database to Couchbase. The one last thing I wanted to do was to foster grade ourselves. So what I wanted to show was a comparison between Couchbase and MongoDB. So here's a join in Couchbase, and here's a similar join in Mongo. As you can see, Couchbase utilizes a SQL type syntax, whereas Mongo, for example, has a whole different query language than most people are used to. So it's a little different than most of us are used to seeing. And it's basically a proprietary querying language that works only from Mongo, whereas SQL has lots of different versatile usages. All right, so what have we done? We accessed Couchbase UI. We took a look at creating buckets. We ran some queries, including joins, and then we accessed that data via code. And then we took a look at a side-by-side query from Couchbase and our leading competitor. And at this point, I'd like to thank you for spending the time with me. Thanks a lot for taking this time. Again, Couchbase is better, faster, cheaper, and more flexible. And this has been independently confirmed by various organizations, including DBTA, which Mark spoke about earlier, and also benchmarking done by companies like Alturas. So again, thanks for your time. I'm gonna switch things back over to Mark.
Great, thanks, Rick, for the demo. And if you can switch back over to me as presenter.
Come in. All right, you should be presenting now.
Cool, thank you. We want to definitely encourage everybody to try out Couchbase. There are free downloads that you can get at couchbase.com to install in your own cloud or on-prem. Both our community edition as well as our enterprise edition. You'll be able to see for yourself, but we also want to really encourage everybody to go the path of least resistance. You don't have to download and install anything if you take advantage of Couchbase Cloud. That's our DBAS. So go to couchbase.com/products/cloud and take advantage of the free trial. All right, so we've had a great time checking out the demonstration as well as going through various examples. And let me just get started by moving into some Q&A. So as we heard up front, Jenna said that you can ask questions in the question area of your console, and we've got a few coming in. So let's get right to them, and we're going to try and actually see if we can do the unthinkable and get you all back to your busy day before the top of the hour. So we'll try and wrap up in the next 5 minutes or so. Any questions that are not answered in that time, we'll answer after the fact via email. So Kim asks, do we offer consulting to assist with migrations? Yes, Kim. Couchbase has a professional services organization, and they're staffed with experts to assist with all things Couchbase, and of course, including migration. There are quick start packages, engagements that are designed to really kind of fit any budget. I'd like to always make the point that our professional services folks are experts. Their goal is to usher customers to self-sufficiency. We don't plant a consultant on site for the next 4 years. We just don't have the time, and we have to make sure that we make you the owner and expert of your own Couchbase environment. So our folks are skilled in getting you self-sufficient really quickly. But on the topic of migration, I want to make sure I also mention that our next version of Couchbase Server 7.0 adds 2 new features, scopes and collections. And this enables subject area specific organization of the data. And we really feel that that's going to accelerate the relational to NoSQL migration effort. So lessening even dependence a little bit more on procuring expert services. We're trying to make it as easy for that migration for you as possible. Rick, how about you field this one from Raj, who asks, is Couchbase useful for ML use cases? I assume he means machine learning.
Sure. Yep. Yes, we are definitely useful for machine learning use cases, and we actually have some clients that are currently using us with those types of use cases. One of the major pizza providers uses us with some ML stuff to help them do some customer forecasting and predictions. And I actually do some of that myself. So I have an ML background, I guess a small ML background. So I utilize Couchbase to do things like anomaly detection and sentiment analysis on data within that Couchbase cluster. So we have an analytic service that you can use to access the data very quickly, and it's very useful for ML use cases. So the answer is yes. The short answer is yes.
Great, thanks, Rick. Manoj asks, can you handle blob data for content management use case? First, let's remember Couchbase is a memory-based document store. But that said, there are techniques for storing blob data on Couchbase and involve chunking the data and referencing it. So in essence, storing the blob data in one bucket with references to the blob data stored in another. And the technique works really well for customers. There's a blog on blogs.couchbase.com, in fact, detailing how to set it up. I recommend you check it out. And we'll be happy to send the link offline to the asker after this event. Okay, Glenn asks, how's the DBAS priced? For Couchbase Cloud, we offer hourly consumption pricing, but we also have prepaid, discounted, what we call Couchbase Cloud credits to reward folks who will sign up for annual commitments. So customers who leverage the Couchbase Cloud credits can scale up their own usage based on their app requirements. We don't penalize you for missing a minimum consumption threshold 1 month or exceeding the next. No penalties. So you pay for what you use. We feel that by combining the performance of profile of Couchbase Server with the customer's ability to both choose the nodes of their infrastructure and configure Couchbase to optimally use them, when you couple it with our competitive price packaging and pricing, we deliver the best-in-class TCO. Rick, how about you field another, then I'll field another, and we'll call it a wrap for the day. Talk about field services. This is probably due to when we talked a little bit about edge computing. So how are companies using Couchbase field services at the edge?
Yeah, so we have lots of companies utilizing Couchbase on the edge. Our mobile offering is actually a very mature offering in the market, much more mature than, say, some of our competitors who have had to purchase companies to try to get their mobile offerings off the ground. We've got several clients utilizing us mobilely. We can do things like access data on the edge, collect that data, sync that data between other edge devices, so peer-to-peer syncing, and also syncing back up to Couchbase Server. We've got real-world examples. For example, one of the shipping companies, one of the shipping companies uses us to help them keep sensors on their guests on the floating cities. And so we've got sensors on about 1,000 personnel and also several thousand guests for one of the chain companies that does, I'm drawing a blank, but one of the chain companies that does shipping. And then we've also got additional examples of Couchbase Mobile in a lot of medical devices. So medical companies will use us to help them track their patients and how their patients are utilizing their medications.
Great. All right, one more question and then we'll wrap it up for the day. Drew asks, what free resources are there for developers to get started with your NoSQL? So I'm gonna totally respect the what free resources, the free part, because there's a ton of great stuff for developers to get acclimated with Couchbase. So again, get the free trial of Couchbase Server from Couchbase.com, or more importantly, go ahead and just sign up and get the free trial of the DBAS, because then there's nothing even to install. You just get started. And once you have the Couchbase environment, take advantage of our SDKs and sample applications. So go to docs.couchbase.com and you'll see what I mean. There's more information than I think you'll even believe there to help get you started. Various SDKs, get started sample applications, Hello World apps, everything you can possibly imagine, all really well laid out and well organized. So this is how Rick and I both got started with Couchbase when we joined the family here at Couchbase. All right, with that, I would like to thank everybody for joining us today. Thanks, Rick, for the demonstration. Hope you all enjoyed it. And Jenna, will pass it back to you. And thanks for your help today, as well as for the opportunity to present with SD Times.
Yeah, thank you both again for a great presentation and demo. For our viewers, again, that was Mark Gamble, Product and Solutions Marketing Director at Couchbase, and Rick Jacobs, Technical Product Marketing Manager at Couchbase. I'd also like to thank Couchbase for sponsoring today's webinar, as well as the attendees for joining us. Until next time, I'm Jenna Sargent.